How are you, my friends? In this video, I'm highlighting part 2 of basic math terms. You know, this is a series highlighting basic math terms, vocabulary in math that we can use. The first part 1, it was about algebraic expressions. Now this is part 2. It deals with real numbers. So let's see, I have mentioned here in this video like 18 words or terms of vocabulary in math related to real numbers. So this is part 2. You can read over and see real number, natural number, whole number, what is a rational number, a fraction, irrational, improper fraction, reciprocal. You can pause it and read. Let's go quickly and start defining. Now we know, everyone knows, real number, as I had mentioned before, every real number is a number that can be used in our daily life. It can be placed on the number line. You see this number line here? We can place, if we can place the number on the number line, then it's a real number. So it can be positive number, it can be negative number, it can be zero, it can be fraction, it can be anything, decimals, it can be rational or irrational. Now, I think you need to know what is the meaning of rational in details and irrational. Before we go there, I will just mention quickly here, what are the natural numbers? The natural numbers are very important numbers. This is a subset of real numbers. So the natural numbers, 1, 2, 3, 4, etc., 5, 6, 7, until infinity. These numbers, we call them counting numbers. If you need to count something, if you need to count chairs or houses, you say 1, 2, 3, 4. So these numbers are used in counting. So we call them in math natural numbers. Now, if you add 0 to this set, so 0, 1, 2, 3, 4, this set is called whole numbers. Now, the integers, subset number 3, these integers are negative numbers, -4, -3, -2, 0, 1, 2, 3, 4, until infinity. Now we can say that 0 is not positive, 0 is not negative. It is an integer, but 0 is not positive, 0 is not negative. Now let's go to rational number. What is a rational number? Rational number simply is any integer over non-zero integer. Please try to remember this simple definition here. What is a rational number? Simple definition. It's an integer divided by non-zero integer. So examples like -8 over 15, 5 over 19, 10 over 3, 0 over 60, 1 over 4, -1 over 9, etc. Also, we can see rational numbers are decimals that are terminating. See, if you see a decimal terminating like 3.75, 0.2, 1.69, 4.31, terminating, you know, terminating is finishing, then this is a fraction, so that's a rational number. So 3.75 is the same as 15 over 4. If you see a decimal number that's repeating, like 5.666666, or any repeating number, listen please carefully, any repeating number, it can be one number repeated, two numbers repeated, three numbers, four numbers, five numbers, six numbers, maybe 4.132, 132, 132, 132. We know for sure there is a fraction equals to that number. You can see other videos how to convert. Just search in the playlist and see how to convert decimal real numbers to fractions. You'll see in details how we can go from repeating or terminating to fraction. What is irrational number? Simple. Irrational number, it is not rational. If we know what is rational, it's integer over non-zero integer. It can be repeated or terminating. Now, the irrational, they are not repeated, not terminating. We can call them ugly numbers if you like. square root of 3 minus square root of 2, pi, minus square root of 17, cube root of 2, minus 6 over pi, pi over 4, any number that we cannot write as a fraction. There is no fraction equals to irrational number. So we call it irrational number. Now, types of the fractions we can have. A fraction represents a part of a whole. Fraction, you know, fraction like fraction 2 over 3, 2/3. You see this one here, simple example, 2/3. When you have a fraction, the top number here, we call it numerator. So please try to learn this word. So learn the word fraction first, and there are types of the fractions I will explain here. And then each fraction has a numerator. You see here, numerator, you can write it down, and denominator. That's another word. We can have an improper fraction in which the numerator is greater than. So if you have 17 over 5, 16 over 3, all these fractions where the numerator is greater or bigger, then we call it improper fraction. A mixed number, what is a mixed number? A mixed number is a whole number plus a fractional part. See, like this one, 3 and 2/5. 3 and 2/5. How do we get that? We multiply 3 times 5, 15 plus 2, 17 over 5. So 17 over 5 is improper fraction. We can change it to a mixed number. Mixed number is a whole number, 3, 2, 5, 7, 6, etc., or minus, and some fractional part, some fraction where the numerator is less than the denominator. So from this slide, you have to know fraction, numerator, denominator, improper fraction, mixed number. Let's see, reciprocal, one word in this slide. Very important word in mathematics, reciprocal. Two numbers whose product is 1 are reciprocals of each other. So we have 2 over 7. If I say, what is the reciprocal of 2 over 7? The answer directly, you flip the number 7 over 2. Because when you multiply them, 2 over 7 times 7 over 2, you get 1. So what is the reciprocal of minus 3 over 4? Minus 4 over 3. Just simple remark at the end here, I put here. If you have b not 0, 0 over b is 0. So 0 divided by any number, not 0, is equal to 0. But b divided by 0 is undefined. This is not real. So if somebody asks you 5 over 0, what is 5 over 0? Some number over 0. Oh, undefined, or not possible, or not real. But if you have 0 over 5, 0 divided by 5, yes, it is 0. Okay. Now, prime and composite number. Prime number, what is a prime number? It's a number different from 1, greater than 1, that has 2 factors, itself and 1. Like simple example, like 2. 2 can be divisible by 2 and 1 only. 3 can be divisible by 3 and 1. 5 can be divisible by 5 and 1. 7. Or we can say the factors are the number and itself, the factors. So the factors of 5 is 5 and 1. The factors of 7, 7 and 1. The factors of 11, 11 and 1. The factor of 13, 13 and 1. I mentioned here the 6 smallest prime numbers, 2, 3, 5, 7, 11, 13. You can find the other numbers after 13. Now, what is a composite number? It's not prime. So every number not prime, prime is easy to find, easy to check. If it is not prime, it goes to composite number. So we can see here 4 is a composite number because we can divide 4 by 2 by 1. 6, 8, 9, see 9? Is a composite number because 9 can be divisible by 9, by 3, and by 1. Even and odd numbers. What is even number? You see even, that means divided by 2, even. Is an integer that can be divided by 2. The remainder is 0. So the last digit in the number is 0, 2, 4, 6, 8. So we can have minus 24 is even number, 0 is even number, 6 is even number, 38 is even number, 10 is even number, etc. Odd number that cannot be divisible by 2. So it is an odd number, ODD, odd number like 11, like 23, 35, etc., etc. Now, look at this diagram of real numbers. This is only just for your information. This is like a gift. I put here all the positive integers, the natural numbers, and the 0 and the negative integers. They end up with integers. All the integers will go inside the rational numbers. The rationals and the irrationals will make the real numbers. So this is a diagram to help you to understand the subsets and the relation between all the subset of real numbers. Now let's go to some questions, three simple questions. How many rational numbers? Just try to apply the terms because it's very important in math to understand the question. How many rational numbers are there in this set? You have to look and compare. See, minus 9.59, 17 pi, 404, 0 over 23, etc., etc., etc. So you can pause the video for a second or so, and then try to see how many rational numbers. I can see the first one, I can see the second one, I can see the third, and I can see the fourth. So I think there are 4. See, the rational numbers are 4 because you can find them here. I found them in this small set. Minus 9.59. It's decimal terminating, completely finished. 404. 404 is integer. 0 over 23. 0 is rational number. Minus square root of 25, which is 5. See, square root of 50, we cannot simplify. So it is irrational number. Now, another question. Find the sum. Oh, this is very tricky and very important. Please try to read it carefully. How do we read this? See, I see 5, I see same number. I can see the fraction 3 over 4, and I can see 1. Very tricky question. 5 and 3/4. That's one number, mixed number, improper fraction. This one here. 5 times 3 over 4. See, 5 we multiply by the fraction. And this, the first one is not multiplication. It's 5 and 3/4, 3 over 4, plus 1 here. Take a minute, please, and try to find the answer, the sum. So you have to do 2 things before you find the sum. You have to convert this mixed number into improper fraction. You have to multiply 5 times 3 over 4. Also, 5 is 5 over 1. Remember, 5 here is 5 over 1. And then the 1 is, you can leave it, make it a fraction. I think it will be 4 over 4, something like that. And then you will be adding. Let's see the answer here. So the first number is a mixed fraction here. So we have 23 over 4. 5 times 4 plus 3. 23 over 4. Now, this is little tricky here. Multiply, look here, 5 times 3 over 4. 5 over 1, that's a fraction. 5 over 1 times 3 over 4. So you multiply the numerator, you multiply the denominators. 5 times 3, 15. 1 times 4, 4. So now look at the sum. The first number is 23 over 4. Second number, 15 over 4. The third number is 1. So you have to find the LCD here is 4 over 4. So when you add 23, 15, and 4, you get 42 over 4. You have to simplify any fraction. So divide by 2, 21 over 2 is the answer. You can leave the answer like this, 21 over 2, or 10.5, or 10.5. You can see a video on adding fractions, many other examples, simple and difficult, on adding fractions, finding LCD. This is one simple example from that video similar. Let's see question number 3. Just true or false. I put 4 questions here, 1, 2, 3, 4. Read it please carefully. Answer true or false, and then you can check the answers on the next slide. Let's read it together. 0 is a rational number. You have to think and use the words. You have to know the definition. You can go back and listen and make sure you understand the rational number. See, in the second question, I asked about reciprocal. In the third, I asked about prime and odd. And the last one, I asked about irrational number. So nice, simple 4 questions. 0 is a rational number. Do you think true or false? Okay, try, write it. Every real number has a reciprocal. Like 5 has a reciprocal 1 over 5. 6 has a reciprocal 1 over 6. 10 has a reciprocal 1 over 10. Can we say every real number has a reciprocal? The answer is no, because 0 has no reciprocal. 0, if you take the reciprocal 1 over 0, it is undefined, so 0 has no reciprocal. Okay, every prime number is an odd number. Prime number that can be divisible by itself and 1. The answer is no, because 2 is prime and even. See, I put here the reason. See, I put the reason why this is false. 2 is prime and even. Last one. Sum of 2 irrational numbers is always irrational. It looks nice, but it's not correct. Because if you take square root of 7 as an example, you have many other examples. Square root of 7, you add to minus square root of 7. Both are irrational. When you add them, you get 0. 0 is rational. See, that's why it's false. You can take another example, pi, and then minus pi. Pi is irrational. Minus pi is irrational. When you add pi and minus pi, the answer is 0, which is rational. Now, as usual, you will find here practice number 1. Find the number of irrational numbers in this set. And then practice number 2, adding, find the value, subtraction. And then practice number 3, usually you find only the answers. Thank you very much for watching. I hope I can see you in another video with another topic. Thank you very much.